I'm Ria.
I'm Juan Pablo.
And I'm Gabby.
And we're
Teens Tutor Teens.
Hey guys, we're here learning today about composition functions. Functions. So everyone knows what a function is, right? It kind of looks something like this. Maybe you've seen examples and such. But what is a composition function? Well, a composition function may look something more like this. It's something that is composed of another function. And this function goes inside, this x, in which x recently and before our variable, but now will become our placeholder for another function. So let's go over some examples and let's see how they look actually. So I've seen many ways how to write this. I've seen like this way how to write composition function, or sometimes I've just seen the plain out. Either way, this way would look the exact same as this way. It would be f of g of x. Basically, all you need to do with this little circle is just add parentheses around that. And even if it's like reversed, okay, let's just say it's g f of x versus g of f. Same thing, okay? We just want to bring that down. So a lot of mistakes that happen is people are getting confused about where to plug in the function. I'm going to give you guys actually some tips on how to avoid misplugging in the function. So let's just start off with an example so I can show you guys. So let's do f of x equals x plus 2, okay? And g of x equals x squared plus 1. Now let's say we have the function f of g of x, okay? We're trying to solve for that. What I would recommend you doing is when you get a function like this, just put everything in terms of this function for now and do not substitute in the x. So what I'm talking about is if you're given f of g of x, basically they're asking you to put g of x inside f of x. So it should look something like this. So that means they're telling you to do this. Where did I get this from? This equation. The x is being changed out for g of x. So you want to put g of x in place of that x plus 2. And last but not least, I would then take out the terms from g of x. Then finally solve the equation correctly. Now let's do an experiment here. Now let's do g of f of x. Same thing. I would just set that equal, place that f of x inside of g of x, so it's going to be f of x plus 1 squared. You have to square that f of x plus 1. And then finally solve for it. So that means it really turns out to be x plus 2 quantity squared plus 1. And that turns out to be x squared plus 4x plus 4 plus 1. So that means you're left with x squared plus 4x plus 5. Now, as anyone can tell a little difference, and as you can see, these two do not equal each other, okay? This and this are not equal to each other, which is why it is so crucial that you get these beginning stages right. Now, if you can do them this way, if you do it that way as well, you are more likely to guarantee to get it right than if you were just, I guess to say, to just plug them in automatically inside the variable. Because sometimes it can be confusing. So we're going to do like one more example, and I just want to see if you guys, in a sense, understand something like this. Now we're going to summarize. So pause your screen if you want to try this one for a try. And we're going to probably just do it one way, because you guys have obviously seen from the example, it wasn't working before. So now let's do, okay, fine, let's just do this. g of f of x. Let's solve for that. So then in my mind, I'd be thinking, okay, since we're doing g of f of x, let's set that equal to each other. F of x is going inside g. This is going inside here. So for f of x, and then we have the whole quantity there cubed, we've got to make sure you have those extra parentheses, plus 1. Then you're going to set that equal to each other. Then you're going to actually plug in the numbers. So in turn, it should look like this. It should look like this. Now, I probably won't simplify this all out, but you should get an answer when they're all plugged in, like something similar to that. Yes. So what did we, I guess, in a sense, learn today? And what does this resemble of? So since we know that f of g of x and g of f of x are not equal, but if g of x equals actually the inverse of this f of x, okay, then they are equal. And before we've proven this, I think in a previous video I have already posted, you can see that when you do f of its inverse, solving for something, a variable, with g in this case will now be the inverse on the outside. It does in fact equal something. They actually both equal x. So this, I guess I would say, this is very key. And I would actually suggest everyone write this down, because this is kind of what's principal in composition functions. So anyways, thank you so much for, tuning into this lesson about composition functions, and I hope you have a great day.